Hi students, welcome to YourPedia education. So in this session we are going to start a new subject in NPTEL questions module, because already we started the NPTEL questions module in the previous sessions with the different subjects. Okay, so in this session we are going to start electrical machines, which is the one of the most highest weightage or most important subject, as well as highest weightage subject in all electrical engineering exams, that is in your GATE, PSUs or in IES. Any exam if you take, this will have highest weightage, one of the highest weightage subject, along with the power systems you may take. Okay, so if you take a PSU exam, any state PSU exam which is for 100 marks exam, this subject will contain around 15 marks of weightage. 15 to 20 marks weightage will be there. If it is a GATE exam, out of 65 questions or out of 85 marks, out of 85 marks, this will have around 12 marks weightage along with the power system. Similarly, power system will also have a 12 marks weightage, nearer to 12, 10 to 12 marks. And if you take a 300 marks exam of your any state PSU exams, like your public service commission exams, that will contain 300 marks pattern. So in that one, minimum 50 marks, 40 to 50, 45 to 50 or 40 to 50 marks weightage will be there for this subject. That is the reason I told you this subject is most important and highest weightage subject in any PSU or any competitive exam. Now in this session we are going to start the electrical machines question. So the advantage of YourPedia is providing all the NPTEL assignment questions. Means we are providing a book, NPTEL assignment book like this, and in this book we are giving the questions which were asked in the previous NPTEL courses, online courses. Some assignments will be given to the students. So those questions we are taking, and we are giving a video solutions as well as a PDF solutions also. Okay, now let's move to the first question of electrical machines in the electrical engineering branch. So let's open the page number 8 and question number 37. Let's start with the first question, which is in page number 8 and question number 37. Now I'll give you the data of 37 question on the board itself for your understanding, easy understanding. So this is the question which was given, which was a simple series motor question, you may feel, but this is a little bit a concept oriented question. So in which two concepts were means two problems were introduced into this one. So first they connect a coils in series connection, then they shift the connection of coils in parallel. So let's read the question, then we'll understand how we need to discuss or how we need to solve these kind of questions. So a 4-pole series motor he has given, and it is drawing 20 amperes at 250 volts running at 600 rpm. So initially this series motor, if you take this is a series motor, and it is connected to a voltage level of 250 volts like this, and this is connected to a 250 volts supply like this, and this is the series coil 1, let me take, and this is drawing a current of how much amperes? 20 amperes from 250 volts supply, and this is running at 600 rpm. This is the running speed of your series motor. So all the field coils are connected in series. So in the initial connection, let me take the coils or number of coils as 2. So for easy distribution of current, because 20 amperes, if you can easily distribute in which one? 2 coils easily. So 2 coils, nothing is mentioned, means you just directly take it as 2 coils only. So in 2 coils, 20 amperes and 600 rpm. This is the initial data given. Then what he has done is, what will be the speed of the motor if the field coils are reconnected to have a parallel groups instead of having them all in series, So if you take the field connections, have you remembered the field connections? How you will connect the field connections means, in your textbooks or in your laboratories, you will represent this one as F, you will represent the other terminal as FF. or you can represent this one with F1 and you can represent this one with F2 like this. So here another one F, another F into F like this. So this is the coils. Now the two field coils are the flux produced by this coil 1. Let us assume because of current flow in this direction, assume the flux is also produced in the same direction. Here also flux is produced in the same direction. So let me take this as flux pi 1, this as flux pi 2. So pi 1 and pi 2 both are in the same direction. So the flux is aiding, we call the flux is aiding. So higher value of flux is there. Then what will happen to the speed? So if you take the back EMF equation of your series motor, so what is the back EMF equation of your series motor? Which will be pi z n p by 60A. Pi z n p by 60A. So from this one, what is the speed? So if you take the remaining all the terms as constants, p is a constant once the design is there. This is constant, this is constant. So from this one, what is n? If you take all the constants as proportionality constants, n is directly proportional to EB by pi. So if you choose this series connection, the flux is high because there is a flux addition is taking place. There is a flux addition is taking place here. So because of the addition of flux, so more flux will be there. As the more flux is there, speed will be reduced. Means this circuit or this motor is operating at a lower speeds, I can say. Now what they have given is, if the field coils are reconnected in parallel groups instead of series. So what he has done is, the next changes he has done is, instead of series connection, the field coils are connected in parallel like this. So because of the parallel connection of field coils, what will happen? So the supply is same, so there won't be any change in the supply. So let us assume here we don't know the current, assume it as a current I. If this is I, this is coil 1, this is coil 2. So what is the resistances of coils? Each coil is manufactured with the same kind of material, same number of turns. So the resistance offered by these two coils will be same. If the two equal resistors are connected in parallel, so how the current will be distributed? Current will be distributed equally. Just like two persons are there, if they have 10 rupees or 100 rupees to distribute, then they will distribute equally. Yes or not? Two persons are there, if they have 100 rupees, they will distribute 50 each. So same persons I am talking about. Similarly, two coils each having a same resistance, then they will distribute the current exactly half of the total value of current like this. So as the current is there, see, if you observe, current is flowing in this one. What is the flux now? Pi by 2. Here also pi by 2. Both the fluxes are aiding or in the same direction. I can say that the total flux will be pi only. But if you take the previous case, this is pi, both are adding. What will happen? Both will be pi plus pi, 2 pi you will get. But here the flux is less. So what is the speed of your DC machine? It is EB by pi. So as the flux is reduced because of the parallel connection of your field coils, the speed will be increased. So this speed N2, which will be more than N1, So based on this simple technique, let's observe the options. Which option I can eliminate? I can eliminate 553 because which will be less than 600. And in the second option, in the fourth option, the speed is nearer to 600. So this is also I can eliminate, because here the change in current will be more when compared to the previous circuit. So the speed also will change a bit higher value when compared to the previous circuit. But even you eliminated one option, at least one option is eliminated. So there is 3 options are there. Now what will happen? How much amount of probability you may have now? Only 3 options. Previously 4 options are there. So you have only 25% of probability to get to guess the correct answer. But now 3 options are there. If 3 options are there, you got an increment of probability of answering or guessing the answer will be 33% you get. So there is an increment in the probability by 8%, by 8 or 9%. 8% you have an increment in the probability of guessing the answer. So now let's analyze this question in schematically. I have explained this one. Now let's solve the question by using mathematical equations of your which one of the series motor network. Now if you take the first circuit into consideration, this is the first circuit, and there is another external data he has given as the torque is directly proportional to the square of the speed. So this is the additional data he has given. Torque is directly proportional to the square of the speed, which will be mostly useful for our problem solving, and also ignore the losses in the machine. Ignore the losses in the machine. So what is the meaning of losses in the machine are ignored means, so whatever the power loss in the coils and in the armature, in the both the circuit configuration will be neglected. If the power loss is not there means resistance will not be there. If no power loss is there means no resistive component. If there is no resistive component here, so what will happen to the voltage drop? Voltage drop will also be same. Voltage drop will also be 0, I can say. Means whatever the applied voltage here, that will be applied across the armature, I can say, right? Yes or not? So why? Because what is the back EMF in terms of resistances of your coils and voltage source? It is V minus IA RA. As it is a series motor, so there is a series resistance will also be added in the drop, in the series drop. So as the RA is 0 and RSE is also 0, so this component becomes 0. So your back EMF is equal to your terminal voltage. So in the both the configurations, the back EMF is equal to terminal voltage. So from this one I can say that VB2 is equal to EB1. EB2 is equal to EB1. Understood or not? So what is EB? What is back EMF EB? Can I write like this in a proportional constant way? It is pi into pi z n p by 60A. So pi z pi n I'll write pi into n. So how I can replace this pi? Because it is a series motor, flux is produced because of the field current. So I can replace pi with the field current also. Because flux is directly proportional to field current, this one. So now I'll add the suffixes for different configuration. 1 for the configuration 1, 2 for the configuration 2, 2 for the configuration 2, like this. Now you know the we know the EB1 and EB2 in terms of IF and N. So as we already know the EB and EB both the EBs are equal because of the losses ignoring condition given. So the IF1 N1 is equal to IF2 N2. So if IF1 N1 is equal to IF2 N2, then what will happen? Now let's check this condition. N2 by N1 is directly proportional to or equal to IF1 by IF2. So this is the first condition. Now let me take the next one, or you can take like this also, no problem. So what is the next? Another given condition is torque is directly proportional to speed square. So from this one, torque T2 by T1 is directly proportional to or equal to N2 square by N1 square, N2 square by N1 square. So this is what the given another given condition. So what is the next condition? We know already. So torque is directly proportional to pi into Ia. This is another condition we know. So in the motor, in the DC motors. So what is pi? Pi can be replaced with if, as we already discussed in the previous session. So torque T1 is directly proportional to if1 into Ia1. Torque T2 is directly proportional to if2 into Ia2. Now let's write this one in here. So torque T2 is if2 into Ia2 divided by if1 into Ia1, which is equal to n2 square by n1 square. So from this one, n2 by n1 whole square is equal to how much? If2. What is the value of field current in the second configuration? It is I by 2. What is the current of armature current? That is I. So in the numerator first part, this is I by 2 and this is I. So what is the second part? This will be I. This is also I. Now let's use this one, n2 by n1 whole square. n2 by n1 whole square is equal to I square by 2 I square by 2 I square. So what is I square here? What is I square here? In the first configuration, what is the current he has given? He has given it as 20. So 20 square. So this is the new current and this is the old current. This is the new current, this is the old current. This value he has given as 20. Now let me rewrite this one as I1, because I1 both will be different, right? Now this is the equation. Let me take this as equation 1. So from this equation we can calculate the next additional data. So n2 into if2 equal to n1 into if1. I'll take this one like this. So if2 into n2, which is equal to if1 into n1. So if1 into n1. So what is if2? So it will be I by 2. So what is n2? n2 we don't know. This is equal to, what is if1? It is 20 amperes. What is I1? It is 600 rpm. So this is this one. So from this one, what is I into n2 value? It will be, so 20 into 2 40, 6 into 4 24,000 you will get. Yes or not? 24,000 we will get. So now you know these values, we know these values. Let's write this in terms of n2, in terms of we need n2, right? So let me write I in terms of n2. So 24,000 by n2. So now replace this I with n2 here. So what is this value now? So n2, or let me take this n2 by n1 as let's remove the square root here. So it is I by root 2 into 20. So this is the after removing of square root or square here. Now I is in terms of 24,000 by n2. Let's substitute here. N2 by n1 is equal to 24,000 by n2 into root 2 into 20. So from this one, if you send n2 to the other side, n2 square is equal to n1 to the other side. N1 is 600 already we know, and other data is 24,000 by root 2 into 20. So if you take this one and take the n2 is equal to square root of this value. So zeros to 30s. Okay, so 24,000 into 30 divided by root. 24,000 into 30 by root. So if we calculate this value, almost we'll get the value of speed as 713.56 something. You will get some decimal value rpm will get. So is the speed is in decimals? No. Yes or not? So the answer will be for this one, the speed will be, what is the answer for this one? It is 714. That is next value. 714 is the next value. So this is how you need to solve this question. This is how you need to solve this question. So what is the concept behind this question, or So what logical thinking you have to apply during solving these kind of problems is, so first you need to have a basic idea about the calculations, or which part of the question is given, which part of the question we need to find. First you need to think about that one. Then you need to think in a logical way that which options I can eliminate from the given options, so that I can increase the probability of getting the answer, right answer among the remaining options. Okay, so the answer will be B. Okay, thank you, all the best.